Thanks for dropping in. I've been brainstorming ideas for future puzzle designs, and one particular mechanism keeps on popping up. Long before fidget spinners were a thing, retractable clicky pens were the fidget toy in school. Not only were they mindlessly fun to click, they were easy to tear apart and reassemble. The mechanisms inside are simple, clever, yet easily overlooked, and that screams puzzle opportunity for me. But before I start the puzzle design, I should probably make sure I can even make a reliable 3D printed clicking mechanism. After all, even with hundreds of real-world examples, there are lots of places where 3D printing can go wrong. Anywhere from printing limitations, tolerances that aren't dialed in, to mechanisms that sound good in theory, but just don't work at all in reality. Finally, the design needs to be reliable. A clicking mechanism that only works 90% of the time isn't satisfying at all. It's extremely frustrating. Eventually though, through a lot of trial and error, I got to this test print, and it works. A snappy, repeatable, undeniably loud clicky button. Sure, it's completely useless on its own, but I'd say that as a fidget device, it's very satisfying. Satisfying enough to release as its own standalone Thingiverse project. Did I mention that it's just as satisfying to watch the mechanism spin around outside the case? It really is a shame that you can't see the action with the case on. Just a moment. This project includes two alternate body designs. The first design has holes running along the side that line up perfectly with the cam as it jumps in and out of sight, a sort of on-off indicator. The second design gives a top-down view of the mechanism as it spins around. Printing the button is extremely easy. The design has no major overhangs, so no supports are needed. I aimed for a palm-sized device, but the walls are chunky enough to be sufficiently rigid if you print it at a smaller scale. I was concerned that the rough 3D printed surface would be a problem with the sliding components, but my own prints required no sanding and no cleanup, even at 0.2mm layer heights. Assembly is just as simple as printing. Insert the button into the cam piece, place the rotating cam inside the button, drop an appropriately sized spring into the cam, and screw on the main body. Commence annoying your friends and family. The design supports a fairly wide range of spring sizes. I found that 15mm long springs with an outer diameter of about 5mm works particularly well, but you can also use the slightly longer springs that typically come with retractable pens. If a spring is too long, or the button feels too difficult to push, just trim a few coils off the spring. I achieved some moderate success by creating my own springs out of PLA that had been softened in hot water and then wrapped around a metal rod. It could work, it's just not very ideal. It is a kind of fun project to try out though. If you purchase springs for the Barrel Cooper's puzzle box, that size works perfectly. You probably noticed that the design has these extra holes in the base and the cam. This is for an optional M3 bolt that you can use for building onto the button. The bolt moves with the cam, which demonstrates both the linear and rotating movement of the mechanism. With sufficient tomfoolery, you could probably turn this into a secondary keyboard function. Before I close out, I want to mention two helpful resources I relied on for this design. The first is this animated click model by Christophe Yamahata. After seeing his demonstration, I completely scrapped my initial design, which would not have been nearly as reliable. The second indispensable resource is a retractable pen video by Engineer Guy, which is a video YouTube wisely recommends to me to rewatch every 6 months or so. Both of these resources do an excellent job breaking down how this mass-produced magic works, and I highly recommend checking them out. Now I have some work ahead of me to turn this little button into a much larger puzzle, but until then, this little thing will be sticking around to provide a very satisfying thanks for stopping by.